With the development of China's transportation industry, many new construction projects involve crossing electrified railways. Traditional construction techniques cannot meet the needs of modern engineering construction. The swivel method of construction can make bridge construction safer and more efficient without affecting the operation of existing lines. Baoli Company entered the swivel industry in 2008 and has since developed comprehensive industrial chain services encompassing swivel device design, production and processing, swivel installation, swivel weighing, and swivel construction. The company possesses large-scale CNC equipment, such as vertical lathes and CNC milling machines, with a maximum processing capacity of up to 10 meters in diameter, capable of meeting the needs of 100,000 tons swivel bodies. Equipped with over 20 sets of professional traction equipment, including 1,000 tons, 500 tons, and 200 tons models, and a swivel team of over 150 members. The company is capable of handling at the same time swivel of multiple bridges. Bridge swivel system. The bridge swivel system primarily consists of the upper bearing platform, upper turntable, central swivel bearing, sliding tracks, support feet, sandboxes, jack reaction seat, boosting reaction seat, and swivel traction system. Installation and construction process of swivel device. Construction of lower bearing platform. For the excavation of the foundation pit for the bearing platform, the concrete for the bearing platform is poured in 2 stages. After the first pouring of the lower bearing platform is completed, the pouring elevation should be slightly lower than the design elevation of the sliding tracks bracket or the bottom of the spherical hinge framework by 10 to 15 centimeters. Sliding tracks installation. After the concrete for the lower bearing platform is poured and reaches the required construction strength, the sliding tracks are fabricated in several sections in the factory, transported to the site, and lifted into the foundation pit section by section. After positioning, the overall sliding track is fine-tuned using adjusting bolts. The elevation is measured at multiple points using an electronic level gauge, with the requirement that the relation height difference within every 2 meters range should not exceed 1 millimeters, and the height difference between radial symmetrical measuring points should not exceed 1/5000th of the diameter of the circular sliding tracks. The framework is securely welded to the reserved reinforcement of the lower bearing platform. Installation of the central swivel bearing. Central swivel bearings are generally divided into spherical hinge type and bearing type. The spherical hinge type is installed in a split manner. Before the secondary casting of the lower bearing platform, the spherical hinge framework and the lower spherical hinge are installed and leveled using the framework's leveling bolt, with detailed drawings provided. After leveling, the deviation between the plane of the lower spherical hinge and the elevation should not exceed ±1 millimeters, and the center deviation should not exceed 5 millimeters. Then the reinforcement is bound. The lower bearing platform is cast again, and the construction of the lower bearing platform is completed. After the construction of the lower bearing platform is completed, the surface of the upper spherical hinge is cleaned. The PTFE sliding plate and the intermediate pin shaft are installed. Grease and PTFE powder are applied, and the upper spherical hinge is installed, completing the installation of the spherical hinge. The overall height difference of the upper spherical hinge should not exceed 0.001 rad. The installation of the swivel bearing type is generally an integrated installation. After the sliding track is installed, the reinforcement for the lower bearing platform and the padstone is bound, and the secondary casting of the lower bearing platform is carried out. According to design requirements, anchor bolt installation holes are reserved for casting the padstone. The padstone formwork is installed, and the padstone is cast. A 3 cm to 5 cm grouting layer is reserved between the padstone and the swivel bearing. and high-strength non-shrink routing material is used. The swivel bearing is installed using the bed motor method, and the height difference of the swivel bearing plane should not exceed 0.001 rod. The installation of the swivel bearing is completed. The boosting reaction seat and the jack reaction seat are cast to complete the construction of the lower bearing platform. Installation of sandboxes support feet. Before installing the support feet, the surface of the sliding tracks is welded with stainless steel plates in an intermittent manner. After welding, it is polished and leveled. The support feet are arranged at equal intervals according to the drawing requirements, and the gap between the support feet and the sliding tracks are reserved according to the design requirements. The surrounding area is sealed with foam adhesive. The support feet serve as safety feet to support the stability of the swivel construction during swivel, preventing the structure from tilting significantly. During swivel, the support feet slide within the sliding tracks. The sandboxes, serving as temporary support devices, are evenly arranged between the support feet. Construction of upper bearing platform. After the installation of the sandboxes and support feet, bind the upper turntable and the bottom layer of reinforcement of the upper bearing platform. Install and position 2 bundles of traction cables to ensure that the direction of the traction cable is consistent with the direction of the swivel. Pour concrete for the turntable and the upper bearing platform, and construct the upper structure and beam body. Preparations before swivel. Procedure 1. Weighing. Before weighing, the swivel bridge support or hanging basket equipment should be removed and the lock released. To clean the gap between the support feet and the sliding tracks, make sure to use a steel ruler or a thin steel rod to fully pass through the gap between the support feet and the sliding tracks, ensuring that there are no foreign objects under the support feet. Remove the temporary sandbox. According to the landing condition of the support feet, arrange the weighing jack, stress sensor, and digital dial gauge. During the weighing process, a jack should be used to apply load in stages, while simultaneously observing the displacement of the dial gauge. When the swivel bridge rotates vertically around the central bearing, the top force at the mutation point should be recorded, from which the unbalanced moment and static friction coefficient of the swivel bridge can be calculated. Perform weight balancing based on the weighing results to ensure that the eccentricity of the swivel bridge after weighing balancing is 5 to 15 centimeters. 2. Try to swivel. 1. Before the try to swivel, conduct a no-load test of the equipment. Wrap the pre-embedded traction ropes around the rotary table and pass them through the jack, pre-tightening each rope individually to ensure that the force exerted on each steel strand of the 2 traction ropes is basically consistent. Upon receiving the try to swivel demand, commence the test run. During startup, observe whether there are any abnormalities in the starting force and record the starting force and the magnitude of the traction force during the swivel process. The try to swivel should include both continuous traction and inching. During the inching process, record the corresponding travel of the beam end when the steel strand travels 3 mm, 5 mm, and 10 mm respectively. This provides effective data for the swivel and closure process. After data collection is complete, complete the try to swivel according to the required try to swivel lingo. 3. Formal swivel. Upon receiving the swivel command, the swivel shall commence formally, with the speed gradually increasing from slow to fast. According to the design specifications, the maximum swivel angular velocity shall not exceed 0.02 rad per minute. The swivel process shall be continuous and uninterrupted, with close monitoring of the sliding conditions of each support foot and the posture of the beam body for any abnormalities. When the swivel angle is 1 degree remaining, start to slow down. When the axis is 1 meter remaining, start the inching operation. After each inching movement, the measurer reports the distance of the beam and centerline. Use this method to perform multiple inching and measurements until the centerline meets the requirements. In the inching state, the equipment adopts a fixed distance mode. That is, the traction stops when the steel strand reaches the set value. The accuracy of fixed distance is 1 millimeter. Using this method can effectively prevent overswivel and improper swivel issues from occurring. After precise positioning of the swivel, steel wedges are driven into the ground on both sides of the supporting feet. The upper and lower swivel turntables are welded and locked to ensure that the swivel unit does not undergo any further displacement. 7. Swivel bearing structure. Through years of experience accumulation and continuous innovation, Baoli Company has developed various swivel devices that can be applied to swivel bridges of various tonnages and structures. Intelligent Force Measuring Swivel Device. Its unique force measuring function allows for real-time monitoring of the force exerted on the support body during the swivel process. Additionally, by cooperating with a force measuring sandbox, it can achieve weighing work, making the weighing process faster and more efficient. This product has been awarded as a scientific and technological achievement in Hebei province, and its level of achievement is internationally leading. The intelligent force measurement and swivel device is suitable for various swivel bridges ranging from 2,000 tons to 100,000 tons, especially for large tonnage swivel bridges that require intelligent force measurement and monitoring and have high safety requirements. Anti-overturning swivel bearing. As the tonnage of the swivel structure increases, the plane diameter of the swivel device also continuously increases. The conventional process of using vibration hulls and grouting pumps for grouting for common swivel devices is difficult to ensure the compactness of the concrete pouring below. The lower spherical hinge of the anti-overturning swivel bearing is hollow and circular in shape, allowing for a narrower cross-section under the same load-bearing capacity, which is beneficial for ensuring dense concrete pouring at the bottom. The lower spherical hinge is equipped with a large-sized steel pipe concrete central shaft, providing higher anti-overturning capability and making the swivel process safer. This device is particularly suitable for swivel bridges ranging from 2,000 tons to 100,000 tons, especially well-suited for curved swivel bridges that require high anti-overturning capability. RPC concrete swivel bearing, which replaces a large amount of steel with RPC high-strength concrete, can ensure the safety of the swivel while reducing costs. As high-tech concrete, RPC material outperforms steel in terms of economy and environmental friendliness. It enhances the overall uniformity, strength, rigidity, and durability of the system. Therefore, it offers a high cost-performance ratio, ensuring safety while also considering economy. The RPC swivel device can be applied to various swivel bridges ranging from 2,000 tons to 25,000 tons. Baoli Company is united and strives diligently, committed to the swivel project with a rigorous scientific attitude and a solid work style. The 85,000-ton swivel of Rainbow Second Road over the Longhai Railway in Shenyang City, the 35,000-ton swivel of Siping Dongfeng Road, the simultaneous swivel of 4 bridges at Beijing Daxing International Airport, the 30,000-ton swivel of Nangliang Expressway, the 110 plus 175 meters nationwide largest span cable-stayed bridge swivel of Jincheng Greenway, and the simultaneous swivel of 8 piers on the Chongqing-Changzhou Road viaduct are all national-level projects that reflect the brilliance of Baoli people. Currently, Baoli Company has completed the construction of over 200 swivel bridges. Baoli Company will surely contribute to the development of China's Swivel project with a scientific attitude, a professional team, and advanced equipment.